waking up at 7:30 for lab. Hey everybody. Yeah, so we are kind of starting to wrap up. This will be our last week of class. Yeah, today we are going to be kind of wrapping up some odds and ends about different kind of more, we're kind of edging more into like just practical tip type things, I think. So today we're going to be talking about some different numbering systems, talking about binary and hexadecimal and why it's probably going to be useful for you. And then some like string operations, and then some stuff with like default inputs into your functions. Then I think probably tomorrow or Wednesday I want to talk about just kind of like different programming languages, different environments, just kind of give you guys like a overview of, you know, obviously Python is super useful. You can use it for a lot of things, but you can also use, and I'll probably actually go into a couple of the resources. Like I think if you want to use Google App Engine, if you want to do like online web-based things, one of the languages that supports is Python. But yeah, then, you know, in terms of like creative coding, like if, you know, the things that kind of break it down to a couple different topics, and, you know, like if you're interested in, you know, making things that move, like you're going to probably want to work in Arduino and, you know, use C++, or if you want to do things that, you know, live on the web, JavaScript is going to be probably where you want to go to. There are a couple other, a lot of options for web-based stuff that can get interesting. But yeah, so without further ado, let's go ahead and screen share and start talking about today's class. So yeah, we're going to talk about strings and default inputs, and also number systems. So this is actually probably going to be a pretty relatively quick class. There may be some, it's going to be a good opportunity in the middle for some just kind of poking around with Python and kind of mess around with strings. But yeah, so I first want to talk about number systems. Are you guys all familiar with like the term binary? Mm-hmm. Yeah, so this is like the native way that computers store numbers. Just like ones and zeros, like, and the way that that actually works on the chip is that like there's like, it'll have a little bucket for each bit, and it'll have either a charge or it won't have a charge that corresponds to a 1 or a 0. So computers all operate in like this what's known as base 2 number system. So our current system, the system we usually use, is decimal, base 10. So your numbers go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 0, and so on and so forth, you know, to get the numbers that we know and love. So it's a base 10 system. So we have each like slot for a digit can be one of 10 values from 0 through 9. And then once you fill that up, you add a digit over here that can then be, you know, so, you know, technically 0, 1, 2, 3, and so you kind of add, you know, your tens place and your hundreds place and your thousands place or whatever. So that pattern you can use with an arbitrary base. So like with binary, it's a base 2, so we only get 2 digits to work with, or 2 characters to work with. We have the 0 character and the 1 character. So 0, decimal 0 is equivalent of binary 0, and decimal 1 is equivalent to 1. But once we run out of characters, then we have to put a 1 over in the next spot and go 1, 0, 1, 1. Then 1, 0, 0, 1, 0, 1, and 1, 1, 0, 1, 1, 1, and so on and so forth. That translates, you probably not have to actually use this very often, but it's kind of useful to know and understand. So 0 is 0, 1 is 1, 2 is 1, 0, 3 is 1, 1, 4 is 1, 0, 0, 5 is 1, 0, 1, 6 is 1, 1, 0, 7 is 1, 1, 1, and 8 is 1, 0, 0, 0. So that's kind of the, so we have the, you know, 1 place, then the 1's place, then the 2's place, then the 4's place, and the 8's place, basically. So instead of, you know, the 1's place and the 10's place and the hundreds place than the thousands place. And then a notation we use for binary is this 0B. Hey, Laria.
Hi.
How's it going?
Good. Sorry for being late.
Oh, no worries. I'll pop this back in. Yeah, so we're just talking about number systems. So binary as opposed to base 10, representing numbers in different bases. And so, yeah, there's this correspondence between any decimal can be written as any base 10 number can be written as a base 2 number. It's just kind of a conversion process. And so when we actually write it out, oftentimes we'll do, so like if we want to tell Python, I'll pull up Python here real quick. So we can actually have give me my number could be 5. So yeah, Python and basically every programming language ever defaults to base 10 numbers because that's the numbers we default to. But you can also tell it, if we're using this 0B notation, you can just give it a set of binary digits. So I could go like 10, and then my number will return the actual base. And you can actually probably
do those little string of ones and zeros is what you get.
All right. Like you can actually just type it directly into the console because the way that, if I type in 5, it tells me, oh, this was a 5. So I could go 0B, 1, 1, 0. That's the number I got. So I could actually turn this to 1, 0, and that would add 1. So, 1, 1.
So, but if I do like 0B 0001, it's 1.
So
0B.
Say again.
No. I think it's. I just did the experiment. No, I was doing 0B and using 0 instead of 1.
Yeah.
But it just recognized that as 1.
Sure. Just like a 0B. There we get you 0, 0. Yeah, there be nothing to do there. So we can add a bunch of trailing zeros, and as long as there's a 1 on the end, it'll still get us a 1. It'd be like if we wrote out 0, 0. Let's see if it's giving us octal. Octal's weird. I don't know why people use octal. But yeah, so if you 0B,
How do you know that's octals?
it's just a guess. It's probably the 0O.
Kind of like how I know what the difference between one cow and another is. Just something I know.
Right. So something that's super common with binary, at least when I write it out, is adding these leading zeros. So, where instead of just being, this is a little bit harder to read because the numbers kind of start, when we add a position, we're technically adding it to the left of the number, but it looks like, we're adding a number to the right. So we'll add this 0-based padding. So we'll start 0B 0000, 0B 0001, and all these leading. You can add as many leading zeros as you want, and they just get knocked out. Especially when we're writing it just as a reference, it's also really common, and we'll get into this why this is a little bit later. It's really common to break this down into blocks of 4 bits, or so 4 digits. So if I was writing in a comment, I might be like, so I need a binary number for some reason, and it might be like 0 1 0 1 1 1 0, and that just gives us even spacing so we don't just get lost instead of having this giant number. What's the 6th position sixth digit here. It's like, it's not that obvious. Kind of sidebar, one of the reasons that you'll see people use like binary stuff is that you can store like a bunch of flags. Flag being like a on-off value. So you could have one like 8-bit number that holds like 8 different on-off like things for your program. So like if you've ever worked with music equipment that has like MIDI things, there might have like a row of like 8 switches that'll be like dip switches that you turn on and off to give it that piece of music equipment an address. Let me actually. Let's see if I can. You might have like a piece of music equipment that has like a row of switches like this. And that's actually just converting it into a binary number that tells you, okay, I've got, this lighting device or this MIDI instrument is on, this DMX light board is on, address 99 or something. So it's just the, or a way to turn on and off different switches. But, so, we talked a little bit back before, way back when we were talking about data types. But 1 byte, so most things in computers are kind of, we work generally with bytes. Whether bytes are, kilobytes or megabytes or gigabytes or whatever. And a byte is 8 bits, and a bit is just 1 binary digit. So this is 1 bit, 0 or 1. This is a 2-bit number. This is a 4-bit number. So something that you'll notice is that like if we were only working with a 3-bit number, all we could get would be 0 to 7. Like we wouldn't be able to store 8 in a 3-bit number because we just don't have the room. But so the 8 bits into 1 byte, you'll commonly run into data that is stored as like a collection of like individual bytes, where like discrete information is held in each byte. The most common things that you will run into with like programming for art is ASCII characters. So this is like a portion of the, I guess the second half of the ASCII table. So these are a bunch of different characters in the ASCII character set, and the numbers that correspond to them. If I go ahead and just do a search for ASCII table, pull up a bigger one. Let's come on. Pull this up and see if I can zoom in on it. So the ASCII table, like, it's a way of encoding like strings as like letters, and each letter corresponds to a number, and that's how it's stored on the actual computer. And so here we start with like number 65 is a capital A, so all the actual like letters get stored as from 65 to 90 are the capital letters, and from 97 to 122 are all the lowercase letters. This is the first half of actually that file. What's interesting is this like first 32, from 0 to 32 are a bunch of non-printing characters, or 30, so 0 to 31. So 32 is the space character, so it actually like shows up and would make your string longer. But you have things like the carriage return or the line feed character, and those can be encoded. Like your keyboard back in the day used to like communicate with ASCII code, so it would just send, for every key you'd press, it would send a number. So if you want to hit and escape, it would send a 27 to your computer. Hit 7, it would send like a bell. It would tell your computer it's like bell tone or something. Or backspace is ASCII key 8. So ASCII characters are 1 byte blocks of data. So like strings that we make with ASCII characters are all just like groups of 1 byte characters, and each byte means something.
So in the byte, it's going to have 0, 0, 0, whatever it is. It's going to have the 5 zeros and then the 3 digits?
No, so the 0B whatever just stands for how we write a binary number out. So
Oh, okay.
when we're working with bytes, since we'll usually be typing it in, and a lot of times be typing it in with decimal notation, just like a regular number, the range that we get is, so in 8 bits we can store any number from 0 to 255. So that'll come up a lot. So another really common application is RGB values or RGBA color values.
So is that why you can work in 8-bit or 16-bit, and it increases the number range and increases the amount of colors you can use?
Yeah, yeah. So like if you like remember back like on Windows 3.1, there's like a 256 color mode.
Yeah.
And that was, there's like a palette of 256 colors, like distinct colors that the computer could give to the screen, or like even further back, there was like 16-bit, or 16, not 16-bit, just 16 color
colors.
Displays.
Yeah, I remember.
And that's so you can stick 16, like 0 to 16 is the range of a 4-bit number.
Yeah.
And so then you got 16-bit color, and now it's really common to have 32-bit color.
Yeah, it's 32 now, but that's
which
just
is
crazy.
So the interesting thing with that is that, so 32-bit color, what's actually happening with that is that you've got 8 bits for your red channel, 8 bits for your green channel, 8 bits for your blue channel, and then 8 bits for an alpha channel, which is like transparency channel.
Sure.
And each of those, so those all get like composited, and we'll talk about this in a little bit later, into like one number that contains, so like the first 8 bits of that number are the red channel, the second 8 bits of that number are the blue channel.
I have a question about it because because this always comes up in my class when we're inputting or making digital images.
Yeah.
And they're like, oh, well, what's the bit? And my thing is like, how much can the human eye really tell the difference between, because this is the same thing with film. It's like, we have like, we have 60, we have cameras that can record 60 frames per second and even 120 frames per second, but really our human eye can really only take in about 24 frames per second. So my question is like, does this information, can we even see it?
It's a complicated question. I would say, but it's actually really. Laria, what's up?
Well, it depends on people. Like probably most people know, but some people are extremely more sensitive to colors, and they can actually capture those nuances. The real question is if the printer can see it.
The printer can't.
because in fact, when I was working as a commercial photographer, we were like using the 8 bit. And I was surprised, and I asked them, they say there's really no point. We ended up with huge files, but we cannot output them in the same way. And at the end, this doesn't make that much difference. But to be honest, since for example, I'm very sensitive to colors, and I noticed that with other people, I could see more than they can. Like in terms of range of tonalities, color cast, and some things bothers me, and everybody seems to be indifferent. So I don't know. I don't know. Yeah, but I don't work 32-bit, for example. I think that's exaggerated too.
One place it might be useful, it might come up useful to have more data there, is if you like to go into files like that, and then like if you had like in the movie reference, if you like to slow them down, or if you like to mess with them, then you've got the data there to be able to mess with it. Whereas if you just do the limited part, you don't have as much to play with.
Yeah, it's like, I guess, two interesting things that apparently VR, like in order to really minimize motion sickness, like 90 frames a second is like a benchmark you should really be trying to hit. But yes, just the different ways. But then also we have different color spaces. And
there's lab, there's all these different color modes.
Yeah, so we have, you know, visible color, and then like that, like the human eye is able to see, and then what colors, you know, can we represent on can we actually show on a screen, and what colored data do we show? But you know, I don't see very much difference between this here and this up here, and
but that could be related to this particular monitor, right?
Yeah, yeah. So
what's the matte paper?
I don't know. It's just off of Wikipedia. It's just a quick link that I saw.
It's probably CMYK. It's probably
sure.
Yeah, it's basically CMYK. Because a printer cannot print.
Because we used to have this stuff that was color match paper. Did you ever mess with that, Jen?
No.
Oh, this is when I had my first design class, and you had like, I don't remember how many colors there were, but they were these silk screened colored papers, and
They're
we had
beautiful.
and yeah, they're gorgeous. And then we had to do all of our design projects by cutting out the little squares and triangles and doing gestalts and all kinds of color manipulations with these printed papers, which might be those matte paper.
Fascinating.
Yeah. Anyway, that just made me think of like.
Yeah, I mean, I think the difference between your, like, especially, you know, back on like Windows 25, you'd have, or Windows 95 or whatever, you'd have an option for like 16-bit color, then 24-bit color, then, or, you know, the difference between 24 and 32 is like, okay, this alpha channel, like that's just, you know, taking, you know, basically values between 0 and 255 on red, and then just like probably interpolating, like, you know, what's the difference between, here's a space that lives between 255 and 254 for red, like, and whether or not that's the difference that matters, whatever. But yeah, so RGB, the color is like going to be probably the biggest time that you see numbers that go from 0 to 255 and like either loop around or just stop at those limits. Sidebar for anybody who's interested in doing glitch art. We also have access to what's known as bitwise operators, which operate on individual bits. And so, like, go ahead and pull up Python. So we might have our, you know, 0B100 or whatever. Hey, it's a 16. You do the inverse of that, and that actually flips. That's equivalent to us being like 0B110. 111. Oh, did I screw that up? Oh, I did screw that up. I'll probably is this.
Cut out shapes and color.
I forget. So one thing that's weird about Python is that
Rubber cement. How did it get them? Oh, okay.
Yeah, so I don't know how to visualize it. I don't know how to print out things as binary. I wonder if there's. Let's see if there's a keyword or something. Nope. Anyhow, so invert bits takes like turns it into 0B0100. The bit shift operator will, so you might be 0B0011 left shift 1 would then turn it into 0B0110. So basically took all the bits here and just moved them one place over to the left.
And added a 0.
Yeah, and it added a 0. It's just like kind of chunking things over. Right bit shift does the same thing. If we had 0011 shifted over to the right to the 1, we get 0B0001. So bit shift to the left if you have a type that's constraining how many bits you have. Anything off to the left, so higher numbers will get truncated. Bit shift to the right, they'll just anything that falls off the edge of the number just falls off and disappears. The OR takes 2, takes in 2. Numbers and combines the bits. So that these 3, you can look them up more. OR and then exclusive OR are just different ways of combining bits together. So if you want to go through an image and do really weird stuff to, there are ways that you can combine these operators and do special things that you could go. So you could go through an image and turn off 1 bit of every color. So you're basically just considering your image as just a string of 1s and 0s and being like, okay, let's take some of these 1s and 0s and flip them up, flip them into 1s, or flip them into 0s, or turn them backwards, or whatever. So you might. So also occasionally you will see, especially if you get into Arduino, you might see some bit shifting. These are impossible to Google for because you'll see somebody have okay, I've got. So one thing you might see would be a right bit shift is equivalent to a divide by 2. So right shift by 1 is equal to divide by 2. Right shift by 2 is equal to divide by 4. So you might see somebody doing something like this, but trying to see, let's pull up Python again. If we're to be 3 to right shift 1, it gives me 3 to right shift. That gives me divided by 2. You want to go and search Google for 42 shift bit shift 1. You're not going to be able to. Google doesn't search punctuation.
Google don't do that.
Right. So searching for punctuation on the internet is really hard. So you might run into something that does weird things, and you're like, I don't. So knowing about bitwise operators here, hopefully you'll be like, oh, I remember that, and I can look it up in a slide somewhere. Rather than being like, I have no idea what that even is ever. But sidebar aside, hexadecimal. How many of you guys have run into hexadecimal before?
No.
I didn't know it.
The only place I've run into hexadecimal is in an old cartoon show.
Interesting. So as much as binary was base 2, hexadecimal is base 16.
Why does it have an inverted P?
That's for the hex.
Yeah.
Oh.
There is a very good reason that we do that. Base 16 is that we use. It's not completely arbitrary, but so yeah, much the same way as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 0, 1, 1, 1, 2, 1, 3, and then 2, 0, 1, 2, 3, 4, 5 for the 20s. Hexadecimal is the same pattern, except after 9 we go to A, B. We add on more digits. So we have A, B, C, D, E, and F. And then once we get to, so F is 15 in decimal, and when we want to go to 16, we go, oh, there's 116 and 0 ones, 116 and 1 1, 116 and 6 ones, 116 and A ones, 116 and E ones. Then there's 2 16s and 0 ones, 2 16s, 6 ones, 2 16s and F ones, which is 2. So that'd be 2 times 16 plus 15, much the same way as 29 is 2 times 10 plus 9. So yeah, so similarly to when we were making things into binary, we can change decimal into hexadecimal. So much like binary had this 0B notation, hexadecimal has this 0x notation. So you'll probably run into this if you are around on coding stuff long enough. 0x is pretty common. But yeah, so 5 is 0x5. 11 is 0xb. 16 is 0x10. 20 in decimal, so the 20 we know and love, can be 0x14. 30 is 0x1e. The nice thing is you can be like, you can be like 0x for d. Let's say to binary. I'll give us binary. Let's go to decimal. That's what I want to do, actually. So we probably can't see it on the video, but there's a little tiny gray in this calculator for it that says 0x40 equals, I know, it's 77. So you can just throw it into Google and just be your 0x number, 2 decimal, and it'll spit out the answer, what the number actually is. Importantly, and you'll see this commonly, this 0xFF, and that corresponds to 255, which you'll also notice is the last, when we were talking about bits and 8 bits in a byte.
Is that why FFFFFF is white or black?
Yep.
I can't remember which one is which. Just do it. Find out.
You teach this for a living.
I know.
Yeah. So our a byte goes from 0 to 255. If you write it in hexadecimal, it goes from 0 to 0xFF. Now, why am I telling you guys about hexadecimal? Like, it seems weird and arbitrary. The really useful thing about hexadecimal is that each digit in hexadecimal evenly corresponds to 4 binary bits.
Oh, I have a question then. Are all the web numbers for colors, are they in this?
Yep. So,
okay, so I know I'm familiar with all the color, like doing the color stuff.
Yep.
I didn't know what I was doing. I just knew.
Just throw some letters in there
I
sometimes.
just throw some letters in there and get color.
Yeah, so web colors are very commonly expressed as in hexadecimal. And the reason it is because, yep. So every 4 bits in binary corresponds to 1 digit in hexadecimal, and it's even. So since, so 1111 in binary is equal to 15 in decimal, which is equal to 0xF. And then so the number after that in hexadecimal is 0x10, which in binary is 00001, which is the same as 0x1. And then 0000, which is 00000, which is 0 in binary. And so, I guess similarly, the pattern here, so each digit is independent of each other digit in this chunk. So I can change, so like I can go from 8F, which is 0B 10001111 to FF, and since this F didn't change, this block of bits is always going to be 1111, and it's just this block. So it's like an independent operation for each digit. I know I'm not explaining that super well, so hopefully the next example will kind of help with that. The big thing is colored. So 2 hex digits, like we're like 255 is 0xFF. 2 hex digits equal 1 byte equal 8, so that's 8 bits of information.
Okay.
So if we have a 6-digit hex number, like 0xFF0000, these first 2 digits here, so like color is commonly expressed as a 6 or sometimes 8-digit hex number.
Yeah.
So this is like any color you do in like HTML or on the web. So like our 0xFF, this first block, these first 2 numbers are red channel from 0 to 255. So like this is a full red. So it's red is 255, green is 0, blue is 0. So we get 0xFF 0000. If you want to do full green with red being 0, green being 255, and 0x00FF 00.
This is blowing my mind right now.
Awesome.
If I had only known what those instead of doing what I used to do. Oh my god.
And so the reason that we use this instead of like binary, because this changes really easily and really predictably. We can change it if we wanted to, go to 254 instead of 255. This would change down to 0xFE. It's super easy.
Yeah, this is like amazing.
And that's because this is the first 8 bits. This is the second 8 bits. And this is the third 8 bits. And so we can have one number that's actually like hiding 3 numbers in it. Versus if we did this in decimal, and we wanted to change, like since it doesn't map to the bits, it's like 4-block chunks, like it's totally random. We can't just be like, okay, I want to change the red channel a little bit. How does that? So you see, let's take 0x f0000. That's this number in decimal. It's kind of a gross number. We wanted to take 1 away from the red channel. So going from 0xFF0000 to FE000. And that just, in addition to, so instead of just changing like the first little bit, it also changed all of these digits. So that whole number changed instead of just the first little bit. So this is why hexadecimal is useful and why we use it in color, because it allows us to have independence between any block of 4 or 8 bits that we want to mess around. So
It's all making sense now. The whole 255 thing.
Mm-hmm.
The whole FFFFF. I always wondered why there were some letters and some numbers.
Mm-hmm.
And I always knew the grays were
Weird.
Get used in HTML.
Uh-huh.
Because I edit our newsletter in HTML, and
You see
I've typed
those.
these in because I have a
Yes.
chart which the RGB is, and then it has like an F number under
Yeah.
a grade number. And I've typed these in before.
Yep.
And that's kind of what you're saying.
Yeah, it's like I would do the color in Photoshop, and then it would just give me this, and I would just copy paste.
Yeah, and so like if you're editing your newsletter and you were like, I want to make this like slightly redder, you can take the first 2 of this and go from say if it was 1C,
We've been using the full one.
I know.
yeah, you might be able to change this to like 2C for like a for your like 5C, and I'll make the number.
I'm totally gonna keep
Make it
that
redder.
now.
Or if you wanted to add a little blue in, you could be like 5C00, 880 or something.
Let's type that stuff in.
Yep.
The color would disappear because it's in the chart.
Yeah. So
I've definitely used the FFFF. Oh, yeah.
Yep. Go white. Yeah.
So the highest one in hexadecimal was the F.
Yep. That's That's not equivalent. Kind of corresponds to like 9 in decimal. Yeah.
I remember the show. It was called Reboot. Did you ever see
Oh
Reboot?
yeah. Oh, reboot. I hear like they're somebody's like trying to bring it back.
Bring it back.
Make a new series.
Is it like about computers or something?
Yeah, it was this. I'm gonna pull it up. It was classic. I'll put it on Image Search. So it's these guys.
Vaguely familiar. Yeah.
Oh, and if you do the big group, I'm sure that hexadecimal's in there. And there she is.
Yeah.
That is hilarious.
Is this like the 90s?
Yeah.
It has to be based on the graphics.
I know, right? I guess
Like they're kind of getting 3D, but they're still kind of crunchy.
Do you remember how cutting edge that looked when it came out? I was like, this is the future.
It's like,
Wow. Yeah.
So
I remember it.
yeah.
Hexadecimal.
So a useful skill in your inventory. Similar, like if you're get like deep in the weeds of image processing, you know, you'll probably wind up using like hexadecimal is a convenient way to start like doing manipulation on individual pixels. You know, doing math to these things or like bitwise operators. Yeah.
So the whole thing with the what was it? Sony adding the was it a yellow pixel?
Mm-hmm.
They're trying to they were making the screen. That kind of messes up a whole bunch of other stuff. Is that right?
I'm sure they had like some translation stuff so that's going to be more like color spaces where they're like, okay, you know, well, for these colors, you know, that we represent in RGB with RGB numbers, like, well, we can, you know, turn on a yellow pixel and have this like synthetic yellow channel that we can add to it to, you know, make our colors livelier or, you know, yeah, increase our color space. Yeah, so I want to also move along before what's next then? Oh yeah, I want to talk about string functions, kind of completely unrelated. So we've made a lot of functions in this class and have done a lot of odds and ends manipulating data. So whereas like integers and floating point numbers and yeah, numbers tend to be real simple, tend to be these like really basic types. Strings in most languages, Python included, tend to be more complicated types, whereas like integers kind of just do, like they're just a number and they can't really do anything from that. We can do a lot of stuff with strings, and a lot of these functions are built in. This link takes us to a big ass list of string methods. I've kind of added a couple of, some of them are like kind of, like I don't really know how there's a whole like format thing that can do like formatting on strings that's like custom, that gets real deep. But some common things, like if you're wanting to mess around with strings, wanting to take in textual data, like on a more practical side of things, if you wanted to say validate, or like make sure, kind of normalize like name information, like let's say you had like a database of names and you were going to use them eventually to like print mailing labels or something, and so you wanted to make sure that every name in your list, like the words were capitalized. There's a string.capitalize function which automatically goes through and your string and like capitalizes the first word of it. The string.center, so we can actually run a couple of these. So I'm gonna have our test string there. So you can go to testing.capitalize. And gives us capital B there. Let's see if that actually changes test string if we returned it. I'm not sure. No. So I just test string.capitalize returned there, so we can have our new string, capitalized string.
That's that kind of variable thing that you talked about.
Yeah. So yeah, so we have our capitalize goes ahead and makes capitalized. Test string.center appends, gives us like, we basically set how wide we want our string to be, and it'll put in the proper amount of white space. We have some test things like starts with. So test string that that takes in like a prefix or ends with, takes in like a suffix. So starts, and it returns true or false. So like starts with pre. There's not pre-bear. Starts with a B. Yes, it starts with a B. Starts with a B. E. That's true. It's a string.find. Might find. We'll find the near like the first like where the substring starts. So it returns kind of an index along our string. So I found that AR starts at index 2. Yeah, so there's a bunch of functions. IsDigit like returns. So IsDigit would be super handy if you're like taking in data from like a text file or something, and you wanted to make sure that we're gonna like take some numbers and divide them later. So like that's string that is digit. Oh, yeah. The string is not a digit, but so say I had a string with like 195 in it. I'm gonna just do this. So if I was reading in something as a string and I wanted to, do some math on it later, I might want to validate it by using this isDigit function, so I could handle a case where somebody gave it in garbage data that wasn't a number. String.split takes a string and so split by itself automatically splits things splits a string into a list based on white space. It also takes in an optional separator, so I could do it on something other than white space. So I could like split it on the character A, so it would break it into blocks of text, except that every time there was an A, it said, oh, no, give me what was before the A and after the A. Split lines are the same thing with new line characters. So if you took in a paragraph, it would break it into, or a whole page of text, it would break it into a bunch of different strings. Each line strip removes characters. Okay. This one's kind of interesting because you can give it a string and it will remove every character that was in that string. Great. No, maybe not. Maybe we can do that up. Let's check it. Oh, it only removes it if it's at the start. Start and at the end. So strip will, like, if you have a bunch of white space, strip removes the white space at the start or end, or it can strip letters and stuff at the start and the end. But something to notice with this is that we have these like optional arguments, and we haven't written any functions that like you can or you have the option to have an argument there or pass in like input or not. All of our functions that we've written are like, draw a square of size. It doesn't, there's no draw a square of, you can include the size or you can not include the size. Versus here, like with string.split, it by default says, okay, I'm going to go ahead and split the string up based on white space that I see. But if you want to give me, a character, I can, break it up on every A or every comma or whatever. That gets us started to talking about function overloading, which is kind of a form of polymorphism. And that in Python, functions can have built-in values for inputs. So I'm going to go kind of work through an example here, because this is kind of a useful technique as you kind of wind up programming things. So we're going to make basically the re-implement the string.center method, kind of, sort of, by making this add padding function. That's going to take in a string and then a value for how much padding to add on either side. So I can copy paste this. So it's going to take in, takes in a string, and then it creates this padding variable by taking the space character and multiplying it as many times as padding width. Then adds that padding to the front and back of the string and returns it.
Padded string. That's me. And the front and the back.
Got our add padding. Let's go on our test string, 5. This bear. A bunch of padding with bear. So let's say we wanted to, so we've got our original function. Let's say we wanted to, instead of just a space, we wanted to write a function that adds an arbitrary character. So instead of just a space, we could use this pad character. So we could write this other function add arbitrary padding. It takes in the string, the padding width, and then instead of just defaulting the space, it uses the padding character. Yeah.
Whoa.
But since maybe we have a couple of reasons that we're writing a couple of different functions that all do the same thing, but just kind of like by default we want it to just add a space, but we want to give the option to have your own special character. So what we can do is we can rewrite this function. We can combine these functions by using what's known as a default input. So when we're writing our function, we can go pad character equals one equal here, our space. And so if I'll go ahead and copy this. Call it with just the 5. This function goes in, it says, okay, I didn't get pad character as an input, so I just automatically make it equal to space. We can also go add padding. Okay, make it 3. And so, oh, I got a character here, and so that overwrote this in my function. So it's still calling the same code. It's just saying that if I have an argument here, if I have an input value, I use that, and otherwise, I use the space here. Moving on to, so that kind of gets us to, so this concept of default inputs for your functions is super helpful in a lot of situations, especially as your code gets more complicated. Because there's a lot of times where you want to make a bunch of things that, by default have some value, but you need the flexibility occasionally to make something that has a different value for that input. So while this default input, so it exists in Python, it exists in JavaScript as well, but it does not exist in Java or C++. Which if you're using processing or Arduino means that you have to explicitly use what's known as function overloading. And unfortunately, Python does not support function overloading. So what function overloading is having 2 functions or more with the same name, but just different numbers of input, different numbers of inputs. So here's like an example for processing, for the same adding example. since processing we can't be like pad character equals that. Like processing doesn't let you do that. Processing is an asshole. So instead, what we have to do is, so we'd write our like complicated version of the function, which takes in as many things that we want to change as possible. Then after that, we write a second function with the same name, so add padding and add padding again. And this one, instead of having input as an input, padding width, and pad character as inputs, just has input and padding width. And all this function does is call and return add padding with the input that we put in, the padding width we put in, and then whatever default value we want to use. So yeah, that's basically how to do the same default inputs that exist in Python and JavaScript. We have to use function overloading to get the same functionality in Java and C++. So yeah. That is basically what we've been, that's class for today. Is that things making sense to everybody in what we talked about today?
Yep.
More or less.
Yeah, I'm super excited about the whole hexadecimal whatever.
I'm excited you're excited.
I'm gonna like make some crazy. Now I'm gonna start making
Oh no, man, now I want to get you into like bit shifting operators because like
yes, that's what I want.
that gets. I mean, like something that'd be interesting
You
with.
can make classes like camp classes with the numbers.
Well, I mean, I'm just thinking of just like you could make. No, you could do a lot of fun color stuff, but.
Nice. Something you could do is like since you've got your 6 digits for hexadecimal, or which translates to a bunch of bits, you could in a bit shift operation. You'd basically change the alignment of those, and so some of the data from your red, green, and blue channels would like bleed into each other.
See, that's that. Yeah.
And your red channel would, like if you bit shifted by 1, your red channel would wind up getting divided in half. Your green channel would like get this information, like a 1 bit of information for your red channel. So your green channel would get like would be like halved, like kind of probably randomly like turned on, like halved or not halved, or maybe double brightness depending on what value it was. And your blue channel would also get some. We mostly get some weird shit going on. So in just these really random glitchy ways.
Yeah, I'm kind of excited about it.
Yeah.
Because you could just attach that all just to improve color.
Yeah. So I probably should try to think if I want to talk about this next time. But file I/O. So anytime you see I/O, it stands for input output. And kind of a useful thing will be like file input output and data streams. And I don't know. Basically, most of the time that you want to use, most of the times that I've used, I haven't done much of it, but most of the times is if you want to use data from like a file or an external source, like in a program you're writing. If it's not built in, like processing has like load image, which lets you load in an image and use it super easy. But like when I get data from a text file, for instance, there'll be like a file I/O library that you'll use, but you'll probably take in the file and you'll have to like have code that reads the file, probably like line by line.
Yeah, you have to break it down.
And stores it as strings. Which I don't know. That's basically. So I guess the process of like going through, like making code that, I guess the process of going through like a string and trying to make sense of it is called parsing. And so like if you were like say you had like a file that had like a paragraph of text in it. So you might take in that file in your program with some sort of like file.read function that is in your library, and then break it down into, so you'd have maybe a bunch of different lines, a bunch of strings, and then you'd write code that would parse those strings into meaningful things. which, so parsing, you'll see that a lot, like string parsing is basically just figuring out how to get your code to understand like content or whatever. Like you might have like a comma separated value spreadsheet, like a CSV file, which is a bunch of numbers that's, in a table format, and it's all separated by commas. So it's about, so parsing that, what you want is like the numeric data, but you get it as a string that's like number, comma, number, comma, number,
Right.
comma. So finding, some code or writing some code that would parse that and like actually return you,
Just,
a list of
just
numbers,
The numbers, not.
format that you can use. Yeah, I mean, there's a lot of examples out there, a lot of code out there, but parsing is the word that you'll need to search. And yeah, so I think next time it'll probably be pretty chill, like kind of wrap up in terms of, but yeah, and just I want to kind of go a little bit practical and talk a little bit about some of the kind of tools and languages and other things that might kind of pros and cons, trade-offs of different directions to go with coding from here.
So that would be crazy helpful.
Yeah.
Mhm.
So yeah, I mean, if you guys want to email me like what sort of area you guys are interested in, I can like dig deeper. Because yeah, I mean, and I mean something else to think about is that I don't know if you guys have used or run into like macros in programming, or in like, sorry, not programming, but in like programs that you use. So like Excel and Microsoft Word and stuff, you can do like macros, which are some little programming language. You can like write tiny little programs that work within inside your thing, or like in your spreadsheet. I'm pretty sure like you can like, so that's also how you automate things like in Photoshop.
Yeah.
You'll like create a macro.
Function based.
I don't know a ton about like writing macros for things, but that's kind of a direct application of these programming concepts. But yeah, so if there's areas that you guys are interested in, shoot me a text or an email, or call me or talk to me, and I can try to dig up some information about ways that you can interface things and like places to start that journey.
I'm excited.
Yep.
Cool. All right.
Well,
Well,
thank you very much.
yeah, take it easy.